is simplifying radical expressions. And it starts out and it will give you two radicals and ask you to multiply. So for example, you could see the square root of 2 times the square root of 7. And the rule for multiplying radicals is that you can multiply them just like normal numbers if they're the same root. So since they're both square roots, I can multiply them and they just stay in a square root and become the square root of 14. The same is true if you happen to have a variable. So I could multiply those, and just like always, there's 7y, the new, and that's true even if it's not a square root, if it's a cube root or a fourth root or anything else. So for example, if I had the cube root of 2 times 32, my answer stays in the cube root, and 2 times 32 is 64, and then I might notice that, that's a perfect cube, because 4 times 4 times 4 is 64. Now most of the homework will ask you to simplify, and they will give you a radical like this. And simplify implies no calculator, so they don't want decimals. When they want you to simplify, they want you to write as simply as you can this without a decimal. But you know you can't take this. There's no perfect square root. 4 times 4 is 16, 5 times 5 is 25. So what we do instead is we think of the biggest square root that will go into 18. And so I sometimes list my perfect squares: 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so forth. And think which one will go into that. And I see 9 will go into it. So I'll rewrite it as 9 times 2. Then I can take the square root is the same as this times this, isn't it? Now another way that some students like better is this. They'll just start breaking down 18 as far as you can. So what times 3 times 6, just so you see different numbers. And then I'm going to go ahead and break down that, because 6 will break down into 2 times 3. And here's the rule. If it is a square root, anything you have 2 of, you can take out. So I have 2 3s. So I can take that 3 out of the radical, and there's only 1 2, so it stays locked inside. And you get the same thing as we got by thinking what perfect square goes into 18. So whichever way you like better. Let's try this one. How about the cube root of 40? Now the factoring seems to work better when you have cube roots and fourth roots, because you might not be able to think of a 40. Or you might be able to go, I know 8. 8 times 5. So I would have cube. And then I know the cube root of 8 is 2, and I still have the cube root of 5. But if you didn't know the cube root of 8, or if you didn't know that 8 was a perfect cube, you would just start breaking down 8. So let's say I break it down into 5 times 8. And then I break that down into 2 times 4. And then I break that down into 2 times 2. So I've got it all the way down to prime numbers. I can't factor any further. Now I have to have 3, because my root is 3. This is a cube root. So if I have 1, 2, 3 of them, I can take it out. So the 2 comes out. It's still a cube root. And left stuck inside is that 5. And so it's the same as doing it this way. Whichever way you like better. Let's do the fourth root of 162. And I'll be honest with you, I know my squares, my perfect squares, and my perfect cubes pretty good, but I don't know my perfect fourth powers. So I'm just going to start breaking this one down. And so if I'm going to break that down, I believe that's 2 times 81, right? Because 81 times 80, 2 is prime, so we can stop with that. Keep breaking down the 9s, because they keep going, don't they? 3 is prime, so we're done. Now, look at my root. It's a fourth root, so I need 4 of them to pull it out. And I have 4 3s. So the 3 can come out through, and that 2 stays locked. How about variables? Let's deal with variables a little bit. Let's just go back to a square root and say I have y to the 5th. Now up until now you've had powers, exponents, and roots that were worked out perfectly. In other words, you could divide the exponent by the root, and we know the power divided by the root is how we simplify it. But we can't take 5 divided by 2, can we? In fact, let's just do that to make sure we're clear on it. And we know that we could write that as 5 over 2, right? But that won't reduce exponent over denominator, just in case you were confused. So what we want to do is rewrite this, the closest number we can write to 5 that will divide by 2. So I'm going to leave my 81 because it's a perfect square. But instead of writing y to the 5th, I'm going to write y to the 4th times y. And y to the 4th times y is y to the 5th, right? So this and this, those are equivalent y's. I haven't changed my problem. But now, if it's y to the 4th, and it works perfectly, it's y squared. So in other words, the square root of y to the 4th is y squared. The square root of 81 is 9. We just did this. This y can't be simplified any further. It's stuck inside. Let's try this one. Make sure you're getting it. Maybe what I would do, if you can, pause your machine and that's a 9. Pause your computer and do this problem, and then look and see if you did it right. So I'm going to go ahead and start breaking down 20. Do 6 times 4. You could do 8 times 3. You could do 12 times 2. Whatever you do, it will work as long as you go all the way down to prime numbers. I know that 9 is divisible by 3, so I'm not going to change that. But 4 is not. So I'm going to rewrite this as b to the 3rd times b. Alright, now let's simplify it. I know that I have 3 2's. So because I have 3 of them, I can pull that out. I know, and I'll just write this over here. And normally you'll do this in your head, but just to make sure you understand. I have b, right here, I have b to the 3rd, and I'm taking the cube root. So I have the cube root of b to the 3rd, which is b to the 3 divided by 3, which is b to the 3rd, and that's 3b, so I can pull it out. So I'm going to pull this out, because it's a perfect cube, and so I have 1b out here, right? Then, for my a, I have 9 divided by 3. So I have a to the 3rd times a to the 3rd times a to the 3rd is a to the 9th. So it's gone. I'm circling the ones that come out. This is stuck inside. I almost missed my 3. So I have the cube root now of the 3 and the b left inside. Alright, are you feeling like you have that? Let's go to divide. Let's say I gave you the square root of 48 divided by the square root of 3. Well, guess what? There's the same rules that apply for multiply apply for divide. So if the root is the same, I can just divide. 48 divided by, isn't it? And the square root of 16 is 4. So we're done with that. How about this one? Let's do the square root of 80y divided by 3 times the square root of 8 is in that radical. So it looks like that. Okay, now both the 80 and the 5 are in square roots, so I can go ahead and do that division. So I will, and I'm going to leave the 3 on the bottom, but 5 goes into 80. What is that? 16 times? Still in the square root, and still a y. And then, you guys all know the square root of 16 is 4, right? So I have 4 thirds, but look, your square root is still stuck there because you can't simplify the y any further. Alright, how about this one? Let's do 5 times the cube root of 162 x to the 4th divided by the cube root of 3x squared. Alright, now this whole thing and this whole thing are both in cube roots, so I can do that division. So I'll just divide my denominator completely out. So 3 goes into 15 5 times, and then it goes into 12 4. So I get 54, right? 162 divided by 3, 54. X to the 4 divided by x squared, we know we subtract exponents, so I have x squared. Now, because this exponent is smaller than my root, it will be stuck in there. I can't simplify it any further. But let's see if we can simplify 54. Let's see. We know that that's what? 27 times 2. And then we know that I have 3 3's. So that 3 will come out. Now this is important because it's the first time you've seen it. That 3 will come out. That 5 is already there. So guess what they do? They multiply. So that came from having 3, this 3, times this 5. Okay? And then left inside you still have that 2, and you still have that x squared. So it stays a cube root, and I've still got my 2, and I've still got my x squared. Now, in this section, 7.3, they have a couple formulas, and for a long time, they didn't ever seem to be on tests, but recently, they have actually been on final exams. So put these down in your notes and memorize, memorize, memorize. The first one is the distance formula. The distance formula says that if you have 2 points and you want to know the distance between them, you subtract the x values and square it, and you subtract the y values and square it. And the second formula is the midpoint formula. And we'll talk about how these came in just a second. The midpoint formula is it's a point. So you're going to have an x and a y, but I have to give lots of room to write what this x and y are because you get it by adding up your x's from the both points and divide by 2, and then you add up your y's from both points and divide by 2. Now, the distance formula, if you think about an xy plane, and let's just draw a random triangle. So if I draw a right triangle, okay, I have 2 random points, and I draw a right triangle between those points. You might remember Pythagoras squared plus this leg squared equals the hypotenuse squared. Well, the hypotenuse happens to be the distance, doesn't it? This side right here will be the y value, 1 y value. Subtract this y value. So that's your y minus y. And it's from, if I use this thing I have to do to get this x value. And I'll use the same x value first. So I'll have x2 subtract x1. So that's this length right here. This x value subtract this x, or this x value subtract this x value. So that's all it is. The distance formula is just Pythagorean theorem. This side squared plus this side squared equals this side squared. But we don't want this side squared, so they take the square root of the other side. Now the midpoint formula, if I have 2 points, again, 2 random points, all we do to get the midpoint formula is we add this x and this x and divide by 2, and that puts us right here in the middle. Sorry, right here in the middle. If I add this y plus this y, that gives us the middle y value. So you add the y's and divide by 2, and it puts you right in the middle. You add the x's and divide by 2, and it puts you right in the middle. So you have to memorize these or be able to come up with them, because on tests they could say, find the distance between, and then they could give you this point and this point. So all you have to do, if you know the formula, is plug it in. It's really easy. So it's easy points. Just make sure you commit that to memory. So you know your distance formula says that you take the square root and you just take the difference of your x's and square it, and the differences of your y's and square it. The key issue is that whatever x value you use first, use the same corresponding point for the y value. So let's say I use negative and I square it, and I'm going to add to that my y values. Again, if I use -1 first, I have to use 3 first. So I have 3 subtract 6 on the y. So 1 subtract -2, we know that's the same as -1 plus 2. So I have 1 squared. For this one, 3 subtract 6 is -3 squared. And that's still in our square root. So I have 1 plus 9, or the square root of 10. And if they wanted a decimal, you could plug that in your calculator, and they do go 3 places, so it would look like find the midpoint. Let's find the midpoint. of -2, 5, and 4, -6. So again, just a formula I have to know. So x plus x, 4 divided by 2, and y plus y plus -6 divided by 2. So -2 plus 4 is 2, and 2, I'll write that. 2 divided by 2 is 1. 5 subtract 6 is -1, and that one won't reduce any further, so it's just -1/2. So that's your answer, and that's your answer. So you'll see midpoint and distance, and again, I've actually seen a couple final exams now with distance problems come up with it, remembering Pythagorean's theorem. Good luck, you guys.